we're going to do the 1B notes. As always, my notes are a little more expanded than what's in the normal MyLabs Plus, but they are very similar. And we're going to be doing the first part of 1B. This is actually my second. I posted something, but I posted just a screenshot of the multiplication table. But this time it'll be better. So, as always, we start off with vocabulary. If the product of two numbers is 1, we say that they are reciprocals of each other. Reciprocals. Now, really, reciprocals are, you're just flipping it. So if I were to have 2/3, the reciprocal of 2/3 is 3/2. Okay. And if I were to multiply those two numbers, you can see the 3's would cancel, the 2's would cancel, or if I just multiply it, 6/6, which is equal to 1. So the product of two numbers is 1, so reciprocals, you just flip it. When we get to the division, you'll see why we're doing it. Now the number 0, or 0n, has no reciprocal. And the reason being is if I were to flip 0n, it's n over 0. Can we have a 0 in the denominator of a fraction? No, we cannot divide by 0. So it's undefined, so there is no reciprocal for 0. Because you can't divide by 0. So now, the next one here is the blank 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 of two natural numbers is the smallest number that is a multiple of both numbers. So that's just the least common multiple. And I'll be showing you how to do this with the multiplication chart as well as prime factorization. But you really want to have the multiplication chart for this section when you're starting to do the work, especially when you get to the adding part. Okay, and then when we're doing this, a fraction has the same number is considered to be the least common denominator. And so when we say LCM and LCD, they're pretty interchangeable. And when we're adding and subtract fractions, we must have like denominators. And that's why I'm saying when we get to the adding and subtracting, the LCM and LCD becomes much more important. And we're just going to do a quick little review of equation work again. If I want to get x by itself here, I have to do the opposite. What's the opposite of subtracting 3? Well, I'm going to add 3 to each side of the equation. Now the x is here. Now negative 3 plus 3 cancels itself out. So the x is by itself. So I've answered and solved for x. Now this next one is not as friendly, but it is a good time to review. So what's the opposite of multiplying 3? Well, I have to divide each side by 3. Now why is this a mean one? 3, I have to do long division into 573. Now if you have the multiplication chart, you can get a little quick start on this, because 3 does go into 57. But I'm going to take it step by step here. How many times does 3 go into 5? Well, it only goes in once without going over. Do the 3. Then I subtract. 5 minus 3 is 2. Then I bring down the next number, which is 7. How many times does 3 go into 27? Well, it goes in 9 times. So there's 27. I subtract, get a 0. I bring down the last number 3. 3 goes into 3 once. So my answer is 191. Okay. And so that's a little long division review. We're going to have to do more of it. And then in C, we're going to have to do a lot of it. But let's get used to the multiplication chart. That will help. So finding the reciprocals, this is where I said all we have to do is flip the number. 2/3 flipped is 3/2. 3/8, I flip it, I get 8/3. Now this next one though, you'll see it in the homework and they're trying to trick you very little bit, but here you got to be careful. 1/3, if I flip it, that's 3/1. But 3/1 really reduces just to 3, doesn't it? And then the other one they try to trick you, 2 is really 2/1, so I got to flip it so it's 1/2. Okay? Just little things, and when you see it, like, oh duh, but you got to make sure you're careful. Now the reason why we need reciprocals is when we're dividing with fractions, Really, we have 3 steps we must do. The first step is we must change it to multiplication. The second step is to do the reciprocal of second number. And the third step is multiply and reduce if possible. Okay, multiplying and reduce. So this first one here, we have a division, we have a fraction. Now really the first thing we gotta do is make 6 a fraction to make it 6 over 1. So if I do 6 over 1, then I gotta times it by 5 over 1. Now 1 and 5, 1 and 6, nothing's gonna reduce here, so I'm just gonna have 30 over 1. But 30 over 1 technically does reduce to just 30. Next one, first number, I just bring down the first number. We have a fraction. We're dividing, so I have to change it to multiplication. I got to flip the second one. Can I reduce anything? Now, it's very tempting to reduce the 3's and 5's, but it has to be something on top reducing with something on the bottom. 3's and 5's don't reduce whatsoever, so I just get 9 25ths, and that's my answer. This next one here, 4 sevenths divided by 4 elevenths. So the first one, the 4 sevenths comes down. We have to flip division to multiplication. Then I can do the reciprocal, so it's 11 over 4. Now we actually have a little bit of reducing. Now 7 and 11 don't reduce, but the 4's do, so I can divide each one of those by 4. So then I get my new question, 1 over 7 times 11 over 1. 1 times 11 is 11, sevenths, and there we go. I do know this is a little funny. It looks like it's an improper fraction with the 11 over 7. We will learn how to get rid of those in part C. And then another here division question. We write down the 8 sevenths. I have to change the division to a multiplication. Then I flip the second one, 7 over 40. And this is even nicer because I can see the 7's will go away. And these are both divisible by 8. So when I rewrite it, it's 1 over 1 times 1 over 5, which is 1/5. So that worked out really nicely. Now we have a couple of equations kind of similar to what we started off with, where we have to do the opposite. We have the multiplication, so I have to do the opposite. What's the opposite of multiplying by 4/3? Well, we're going to divide by 4/3. And then I got to change this into a fraction as well. Now 4/3 divided by anything divided by itself is 1, so really we're left with x equals. That's what we're after. But we are dividing by a fraction. So 48 over 1 times 3 over 4. I always have to change division to multiplication, then multiply by the reciprocal. Now 1 and 3 doesn't reduce, but these are both divisible by 4. So 48 divided by 4 is 12 over 1 times 3 over 1. And again, use your multiplication chart. This is all on the multiplication chart, this division. 12 times 3 is also on the multiplication chart. So it's 36 over 1, which is just 36. Because remember, I don't need the 1 on the bottom. If the 1's on the bottom, I can get rid of it. Now, over here, when it's the 1 over 5 like this, I need this 1. If it's in the numerator, I need it. If it's in the denominator, I don't. So now this next one looks very similar to the other one, except the numbers are gigantic. We're going to divide by 49 over 64. Divide by 49 over 64. And so then I have to do the 7/16. That just comes down. Change division to multiplication. And then reciprocal the second one. Now, I could try to multiply 7 times 64 and 16 times 49. And they're very big numbers, and I really don't know what they are. But as always, I want to make sure I reduce if possible, because this makes a huge difference. I want to divide each of these by 7. Again, if I look at my chart, I'll see 16 goes into each one of these. So 7 divided by 7 is 1, 16 divided by 16 is 1, 64 divided by 16 is 4, 49 divided by 7 is 7. So now, instead of doing 7 times 64, I'm going to do 1 times 4. Instead of doing 16 times 49, I'm going to do 1 times 7. If you don't see that reducing is extremely valuable right now, I can't help you on this. You got to see what a huge difference that is in reducing. All right, we got 2 more questions for this first part of the notes here. So what we have how many shorts can we make from 30 yards of fabric? I don't know if you've ever seen fabric, but it's called a bolt. It's like this rolled up, thing of fabric. But if you lay it all out, it turns out into this giant rectangle that's 30 yards long. And it takes 5/7 a yard to make a pair of shorts. So I'm going to do 5/7. I'm going to really cut it into all these 5/7. So what I'm doing is I'm taking the 30 yards of fabric and I'm splitting or dividing it into pieces that are 5/7 long. So again, I'm dividing fractions. So I have to do 30 over 1, and then I got to change it to multiplication. Then I do the reciprocal of the second number. And this is a good one because I can reduce. So 6 over 1 times 7 over 1, that's 42 over 1, which is just 42. So I can make 42 pairs of shorts. Alrighty, and this last one of the section, this is kind of a mean question, but it's a good one to do together. So basically we have John, he sells seeds to all these different places, and he drives around a lot. A salesman does a lot of driving. So now where we come down to the question is, how long was the total trip? And they want you to kind of think about this in equation form. So if he's done 5/6 of the trip, so what that's saying is 5/6 of the trip is 210 miles. Because he drove 210 miles, and this was 5/6 of the trip. So now, from unit 1A, we were talking about 5/6 of is multiplication normally. The trip is what we don't know, so we're going to let that be equal to t, equals 210 miles. And so now when I've written like this, you say, I know how to do this. Because it's equation, there's multiplication, there's a fraction. So I'm going to divide each side by 5/6. And again, 5/6 divided by cancels. T equals 210. I got to put it over 1 times. Then I got to change division to multiplication. Then I do 6 over 5. So I multiply by the reciprocal. Now 1 and 6 don't reduce. 5 does go into 210. But it's a little over the chart. I really can't see that far. So if I can't do that, I have to do long division again. Dope. So 5 into 210. And again, the multiplication chart doesn't go that high, so I got to break it down. How many times is 5 going to just 21? Well, that's 4 times. 4 times 5 is 20. I subtract. 1 minus 0 is 1. I bring down the 0. How many times is 5 going to 10? Just twice. 2 times 5 is 10, so it goes in evenly. So my new question right here is 42 over 1 times 6 over 1. So I know my bottom is 1, so that's nice. Unfortunately, 42 times 6, I don't have that memorized either. So I'm going to do this in green to make it stand out a little. So I got to do 42 times 6. 6 times 2 is 12. 2 carry the 1. 6 times 4 is 24. 24 plus 1 is 25. So his total trip was 252 miles. So how long was the total trip? 252 miles. Now sometimes they like to ask the question, how many more miles does he have to drive? Well, the whole trip is 252 miles. He's driven 210 miles. So we got to see what's left, so I got to subtract. So there's 42 miles left. Okay. And so that's the end of part 1B. The next 1B part 2 is up already. I hope this helps. And that's the end of this.